Okay, so we're making this fractal here, and as you can see, it it definitely is a fractal, right? Let me bring this over here to modeling, right? And of course, with a fractal, you as you go in, it looks the same as you go out, right? So that's what we're going to do. So the first thing we're going to do, though, is we're going to upload a file called the template, right? And if you do that, you're going to get one that looks something like this, right? So it's got a couple of things in there. Something to do with the setup. When every time you run, it deletes everything that's there before. Adds some lights, and this is we're going to use these two functions here for our coding. So if you run it though, right, if you run it, you should get no error and nothing is there. So the first thing we're going to do is we're going to make our first triangle. So the first triangle looks kind of like this, right? We're going to start at 0, 0, it has a side, and we're going to make these vertices. So V0, V1, V2. So if I go back to Blender, we're going to first define a function. So we're going to say define Sirpinski. I want to say Sirpinski Fractal. So it says, well, got it. Sirpinski Fractal. And so we need a couple of things, right? First thing is we need how big is the side, right? So side, let's make it like 3. Right, and then we need the vertices. So after that, we need the vertices. So I'm going to say, oh, actually, we're going to need vertices. So we're going to need a set of vertices. So I'm going to say verts is equal to, this is a list, and we're going to also make edges, right? So this is a mesh. So edges, and we're going to make some faces. So we're basically making our own mesh here. I think I got it. So we'll get to each of those step by step. So the vertices comes first. So vertices comes first, and I'm going to make 3 like I showed you here. And we're going to be consistent. We're going to do V0 upper left, right, and then the bottom one. So I'm going to say V0 equals, and then what we need here is we need um, 3 values. We need X, Y, and Z. Well, the left vertex will be minus side uh, divided by 2, right? And then y would be 0 and x and z would be 0. So this should be vertex 0. So just to show you one more time, this is this one. So side, this is the side minus side, right? That's a negative side, that's a positive side. So let me do the other two, right? The other two vertices. So V1 is to the right, so that should be side, and V2 should be the bottom. So the bottom is going to have to be calculated. So we need the Y value. The X and Z value are 0, but the bottom is going to, we know these are 60 degrees, right? So equilateral. So we know that sine of 60 is H over side. So that means H is equal to side times sine of 60. So uh, so when we get to the third one, this is 0. And then we're going to say, okay, it's minus math, well, side, and then times math sine. And we need the angle here. We're going to use this angle 60 a lot, so I'm going to just declare it. And it has to be in radian form too. So I'm going to say rad 60 equals math radian radians. It could be radians. Radians. So we'll see. Rad 60. So rad 60 is the angle. Rad 60 and then 0. So we have our 3 vertices. I'm just going to run this to see if I have any error. It looks like it's okay. So radians is good. So now what we need to do is we need to add these vertices, these 3 vertices to this list. So we're going to say verts extend. And inside, we're going to have some brackets, and we're going to do V0, V0, V1, and comma V2. So it's in there. We need this for the next step, and that is to make the object. So when you make the object, you have to have a list of each of these. Okay, so I think we could make the object now. So let's say make object. Okay, make object. And I'm going to send each one, even though some of them have nothing in there, it's going to be okay. But the verts do have the points. So I'm going to say edges and faces, right? And let's give it a try. I'm going to run and see uh, I didn't run the function, right? So you have to run the function. So I have to go down here and I say execute this function. So I'll just copy it and execute it, right? So let's give it a shot. It says, okay, so look at the points, right? They're not easy to see every time. Maybe in modeling or layout, you can see them better, see? But the 3 points are there. So now we would like to make the edges, right? So I'm going to go back to scripting. So I'm going to say edges. Uh, So the edges are the vertices, right? The vertices we have to index, these vertices are indexed, and we have to just use the index of each vertices, each side. So edges, uh, extend, and we're going to do the same thing. And what we're going to do, oops, I took this inside, I should be inside. So here we go. So what I need is the edge. So I know this is index 0 and index 1. So I'm going to use 0 to 1 is an edge, right? And then I'm going to put a comma and then brackets again. And I know 1 to 2 is an edge from these vertices, right? And then the last one is 2 back to 0 is an edge. And that should give me some edges, right? So if I run, it looks like I have some parentheses. It says uh, it looks good, but I don't see anything right now. Oh yeah, I guess I have to make the edges before I make the objects, right? So somehow I got down there. But let's make the edges before we make the object. So it says float. I'll have to check that. Where is that? So I'll check. So I think this has to be a comma, right? So comma. I think we'll make that a little better. So we have the edges, right? And now we need the faces, right? So the faces is going to be pretty simple. You just need to give me the vertices that make up a face. So there's only one face here. So I'm going to say faces that append. There's only one. So just going to append and I'm going to, these are parentheses, and then I'm going to say, well, 0 and 1 and 2. So index 0, 1, and 2 will make the face, and then I should see um, a face, right? So yeah, so I got these things reversed, right? Should be close bracket and then parentheses. So close bracket and then parentheses, and now they should match, right? So finally, I have my first triangle, right? So the next step is going to be to make the others. Okay, so what we're going to do is we're going to make another function called the left. I'm going to do the top first. So if you remember, there's going to be a top triangle over here, right? So I'm going to call this fractal. I'm just going to say left, so Sirpinski, excuse me, top, right? The thing is, we need some information into this function from the previous one because each of the subsequent triangles are using information from the previous triangle. So what am I going to send? I'm going to send V0. I'm going to send V1, those vertices, V2. I'm going to send in the side, right? And I'm going, and I'm going to send inside. Okay, so that's what we need for right now. So, so I'm going to copy some of this code because we're going to reuse it, uh, reuse it, and I'm going to copy this code, right? So I'm going to say, and I forgot, let's say oops, wrong one. Did I put it in the right place? No. Let's undo. I have to put it right here. So I copied this code and I'm working in the Sirpinski top. So what I'm trying to do now is make the top So what has to change is these vertices, right? Everything else really stays the same, but the vertices have to be different. So what do they have to be? So let's take a look. So I'm trying to make this triangle over here, right? So these are my new vertices that I need for this triangle at the top. So I know that this side is going to be, for my geometry, I know that this side will be half the other side. So that's going to be different. And then what I'm going to do, the idea is I'm going to find this midpoint right here. And if I find this midpoint, I can find V0, I can find V1, and I could also find V2, which is the midpoint. So the midpoint is from the other triangle, right? From the previous triangle, will be the X and Y values of V0 and V1. So the first thing I'm going to do is find the midpoint. Okay, so I need to find the x midpoint, and like I told you, it's the x value of v0 and v1, right, from the previous. So let's say v0, but v0 has x, y, and z components. So I want the first component of that um, vertex, which is 0, right? And actually, if I'm doing midpoint, so plus, and then remember it was V1, and I want this X component, right? So, and then I'm gonna add those two and get the midpoint of the X. And I want the Y also. So now I'm going to change this a little bit. This will be the y component, which is the second one of the two. So now I have the midpoints. So now I can go and I can calculate V0, right? So V0 is up to the left, right? Up to the left uh, of side one. Now, I just want to make sure that you understand when I call this function from here. So I'm going to call that function from here, right? And I'm going to divide the side by 2. So when I call that, I'm going to take the side and divide it by 2. So it will be half the previous. And then, like I said, I'm giving you all these points from the previous one, right? So to get back to that. So V0 will be minus psi divided by 2, but Y will be this part, right? Like we did before, but it'll be up because that's positive and X was 0. So the other V1, again, I want to just show you. So we went up 60 degrees up here, right? And then we're going to go to the left and to the right. So I'll check my mind later, but we'll see. So this will be psi divided by 2. This will be plus to the right and 0. And then the vertex, remember, V2 is the one at the bottom. That will just be mx, comma, my, comma, 0. And like I said, I think the other things just stay the same, right? So did I check it? So I'm going to check it on C, run. So I'm going to look at this, and it looks like, this. I'm going to just check this out. So I think I forgot to close this. This is a function. It needs to calculate its value, and I didn't close it. And there's another little error. Yeah, when I call the function, I don't need these. Okay, so there it is at the top, right? So it looks pretty good. Now the interesting part about this, if I call the function inside itself, see, so look what I did. Yeah, I called the function, from the main one, right? And then ran once, there it is, and it gave me that triangle. But if I run this one in here, it should give me the next triangle, but the problem is this is infinite now. If I do this, it's going to run forever because it doesn't stop, right? So I need to introduce a recursion. How many times I want it to recur? So I'm going to say recur equals, let's say, 3, right? So recur equals 3. And now I need to send that in. So let's say recur, and I'm going to say minus 1. Every time I recur, I'm going to go minus 1. So now I have recur over here. Recur, so I'm getting a number in here. And this is how I'm going to do this. If the recur is greater than 0, I'm going to do all of this. See? And I'm going to just tab in. And then I'm going to recur minus 1. You see? So every time you recur, you're going to decrease this number by 1. So At some point, you will not execute this if, right? So if you don't have that, it's going to go infinite. So let's see. Um, just want to check. Did it give me an error? No, it's okay, but I want to check why it didn't give me a couple more. Hey, I think I checked my math, and what I have to do is actually start from the middle, right? So I have to say mx minus side and my plus. So I have to start from the middle that I calculated. So this is mx plus side, and this is my. So my plus side. So let's give this a try, and now it looks like it's okay. See, so what it's doing is just making smaller and smaller triangles on the way up. Okay, so this, if you notice, right, to do this top one, all we really had to do was calculate the middle, right? And in this case, the middle was between vertex 0 and vertex 1. And then we calculated, using a little trigonometry and arithmetic to calculate the new vertices, and everything else stayed the same. So I'm going to see if you can do the other two, right? So what I would do next is I want to do the left, right? So I'm going to call this left. So uh, left, and everything stays the same, right? I'm going to copy this one. I'm going to call it left. And I might just comment out the top just so it doesn't interfere with what I'm looking at now, right? So I'll just do left. So I'm doing left now, right? And I'm going to rename it left. And so here's the deal. Again, we have to watch where a middle is. So if I go to the picture here, and I'm doing the left here, so I didn't draw it, but what I would do is take this, and I'm doing the left, and I would move it over here to the middle, right? So this is the one that I'm trying to do. So um, so you see, our new vertices for the left is we need to find this middle, right? So this middle is really right. So which two vertices from the previous triangle will you use? You'll use V0 and V2 to find this point. I don't have it exactly in the middle, right? I mean, a little further down possibly, but oh, anyway, you see, you want that middle point. So it's between V0 and V2, right? So you have to adjust this code. And if I go back, right? If I go back to here, so you see my new x will be between 0 and 2, their x value, and then between 0 and 2. And the next thing that I have to consider is where is this V0, right? So I have my middle now, and I want to calculate V0, V1. Well, I'll do the easy one. V1 will be just the middle, right? So if I go back to Blender uh, and I say V1, well, that's just the middle. And um, I don't need this, right? So I'm going to ask you to try the other vertices, right? And then if you have the left, then we're going to do the right. And then I'll see what's next. Okay, so you have to figure this out, right? But I think it's just a little bit of arithmetic. Give it a try. So if you have your left, top, left, and right working, then this is what we want to do. We want to call all three, of course, from our original function. But we also want to call all three from each of the top, left, and right. You see, that's what makes this recursive so interesting. So you see, from each one, I'm calling all three. So when you call all three, that's when we get this beautiful fractal, right? So let's see, let's see how you did.